Okay, let's look at some data representation facts on how, or as they say, schemes. That sounds like something nefarious is going on, but what they mean is what are the different ways or schemes that we have in place to represent binary, right? So the computer needs to see binary. What's the process for turning that into some text? How's that going to happen for us? We need to see that text. Computer needs to see binary. We got to have a go-between. Well, the first one was ASCII, and I often use that as an example because it's very simplistic. And you know, 1963, so you're going back then, and it could only have 128 different characters. That's all it could do because you had the values of 0 to 127. And you can look up what an ASCII, you know, just put an ASCII table and then you'll see it. Well, that doesn't really help the rest of the world. That's a problem. You know, when they first started this, they're really thinking of how do we get this done? For instance, if you look at the time here, 1963, a large portion of this is how do we get a man to the moon and how can computers help us do that? And ASCII then is to solve this specific problem of representing data for specific needs. And ASCII then is limited to, you know, American languages, basically. English language is what I should say. Now, obviously, anything that's coming off of our alphabet, German or whatever, is going to kind of be there, but there's going to be a lot of different characters that are used across different languages that are not there. So Unicode is what we use now. In 1992, the Unicode Consortium released the first Unicode, and it uses 16-bit encoding. And so it's capable of representing millions of different text characters. And that's enough space to do a lot of things with. And so we deal with different versions of that, Unicode, UTF-8, 16, and 32. You can guess what these last numbers are. But for example, web pages are often just use UTF-8 because that's enough for them. Right, and then developers have even started assigning Unicode values to pictures called emojis. And that means you can go out and look at the hex value, right? That's a hex comes in on this that says, oh, that's this emoji or that's this letter. And that prepares us for lots and lots of stuff. You know, there's tons of graphical languages out there, notably Chinese, Japanese, the different versions of Chinese that should have a character representation that's not some kind of letter that the rest of the world uses. So you got to provide for that. So this is the basic way that we can deal with that data of saying, well, we can put a set of ones and zeros here and translate it to an A or a B or an emoji, something like that.